the device software. So currently what we saw is like when we create a device, how can we communicate with IoT core, and then how can we perform different actions on IoT core. Now we will see like how can I have a device, I can program a device, and then that device should be able to talk to the IoT core. Now, Amazon FreeRTOS, it's like one of the natively supported operating systems from AWS itself for the IoT devices, so that we can like write a firmware using FreeRTOS and then put that into the microcontroller, and the microcontroller will basically be able to do all the local actions as well as communicate with IoT core. And it allows us to also do like remote updates, over the air updates, all that stuff. There's also something called as IoT device and mobile SDK. So basically, like when we don't want, or uh, if FreeRTOS is not going to be our thing, AWS IoT has all of these other ways or the SDKs through which we will be able to communicate with the IoT core. Now, if a mobile device wants to connect, this mobile device needs to basically have this IoT device certificate, or it needs to have the IAM user credentials so that it can talk to AWS IoT. Similarly, when an AWS user has the credentials or the permissions, an IAM user has the policies attached that so that it can publish or subscribe to messages in AWS IoT, it can do that. Or we can have a device with those IoT certificate and policies attached to that certificate. So a device can be communicating with the AWS IoT. Now, this is something that we will look further into. So we will look into like how can we use different tools in order to communicate with AWS IoT core. We will begin with Python. So the way I showed you how to create a thing and then how to publish messages, it was like kind of not very easy to get started with. But there's also like one more option called as onboard in here. So when you click on onboard and get started, basically what AWS IoT console does is like it creates an SDK. It provisions all the necessary things in it so that it can send message, subscribe to messages. It will be running as a Python script. It does not necessarily have to be Python. We have options. So when we click on get started, it says that these are the 3 steps for us to get started with AWS IoT core: register a device, download the connection kit, and then configure and test your device. Let's click on get started. I'm currently on Mac, so I'll click on OS X. So these are the 3 different SDKs that AWS IoT provides at the moment. I'll click on Python. So when we download and when we want to run it, we should make sure that we have Python installed in our computer, Git installed in our computer, and the computer should be able to make TCP connection requests on port 8883 on the public internet. So once all these 3 are satisfied, our program will run. I'll like explain how this works again. Let me click on next. Let's say I want to call this Python simulator. Okay, next step. And then, so basically it will create a package for us. It will create a zip file which will have all the files, certificates, everything in it for us. So it has created policies, it has registered the device, and it also comes along with the Python SDK, which will have start.sh. I'll explain how that works as well. Now, in order to download it, let's click on Linux OS X. This will try to download it. So I'll go to devices and then it will be with the name connect device package. Let's say I want this to have the name Python simulator. Save it. Got saved. Okay, cool. Next step. What we need to do is like unzip the package and then change this start.sh into execution mode and then run that script so that the device will start talking to AWS IoT core. Now, 2 things that we usually do is like one is authentication. We generate certificates. When we have done this, it has automatically generated those certificates and it has put it into the zip file. Similarly, the authorization, all the 3 steps that we just followed, it will have also created a policy and attached it to this particular device. You can either do these things and then wait for messages to appear here, but I'll show you from the MQTT test client anyway. So I'll click on done and then I'll show you how what it has done. So in the things, you can see that a new thing has been created called as Python simulator. And this one will have one new certificate which will have its own policy that the get started steps has created. So that's why you see Python simulator policy here. And when you click on that, it will have the policy that says it can publish, it can receive, it can retain the published value, it can subscribe to these topics, it can connect as these three clients. Basically, it has already created a template of that, irrespective of which SDK did we choose, Java or Python or the Node.js. Okay, anyway, so I'll go back and then click on test, go to MQTT test client. If let's say I want to subscribe to all the topics in this particular MQTT broker, I can simply subscribe with the character hash. So it will subscribe to all the topics, any message that gets published into any topic in this broker, it will basically display those messages here. Now, while this happens, I'll come back and then I will extract this. Dot dot. Here I have the Python simulator. I will do unzip Python simulator into the directory called Python simulator. Okay, so I should have a new folder now, which should be called Python simulator. So I'll do cd Python simulator, and then it has these 4 files. So it has the device's certificate, device's public key, device's private key, and it also has this start.sh. Let me show you what that is. One of the things I had to do was like make that start.sh into execution mode, right? So I'll do chmod plus x start.sh. Now let me open this folder in VS Code, and then I'll show you what it has. I mean, you know, the certificates, it only has these values. So all these private key, public key, all of that stuff. But when I open start.sh, it will have a bash script. So what is in this bash script? It will first, okay, here it says like open with bash and then stop the script if there is an error. The first thing it will do is it will check if there is any file called root-ca.crt in the current folder. If it is there, it will jump. If not, it will print downloading the root certificate, and then it will perform this curl command, which basically downloads the root certificate from this URL, and it will store it into this file in the local directory. Also, it will check if there is a folder like this in the current directory. We know that there is no such file like this in the current directory. There is no such folder like this in the current directory. So it will perform git clone, and then it will get this one as well. And after it has downloaded this AWS IoT SDK for Python, it will have to perform installation. So it will also do these things so that the SDK gets installed. And once that also happens, it will run the sample application by executing this script Python, and within this folder there will be the samples folder, in that basic pubsub folder, and within that there will be basic pubsub.py, and in here it specifies whatever is the endpoint and what's the root certificate, what is the device certificate, and whatever is the private key. So it does all of these things and then it will execute it. Okay, so I will do ./start.sh. Now it will do certain things. So here, if you see, it has downloaded the root certificate. Downloading this, it should have downloaded, and then it should have cloned the AWS SDK as well. And when it was trying to install it, it was already installed in my computer, so it is fine again. Now, when it was trying to run this Python script, it was not able to execute it The reason being, uh, it needs Python 3, but by default, Python for me is Python 2. So what I'll have to do is like come back to this one, and in the script, in the last line, I just have to put Python 3 here. So in Python 3, when this program tries to execute, it will start running. Okay, let me clear this and then I'll start the script again. Now it should get connected to AWS IoT core and then it starts sending messages. Now you can see it here that this is what it is sending. The SDK test Python is the topic and this is the message that it is trying to send. Let me quickly stop this one and then clear it. And then if we see now root ca.crt has been downloaded, and also this another folder also has got downloaded. So we can look at it here, like there is this folder, within that there is samples, and within samples there is basic pubsub, and in there is basic pubsub.py. This is the actual Python program that is getting executed in order to publish the messages. So in here, in the last, you should be able to see the messages, whatever arguments dot message and sequences loop count, because that's what this is like publishing. Okay, so this is like one another quick way of using Python to, I mean, if you want to create a simulator, IoT device simulator, you can download, I mean, you can go ahead with this get started option and then you can see how you can send messages in here. Just for fun, I'll add a new key. Let's say I'll call this skill. And since I made this change, and if I do dot start sh the again, it should publish messages which should have event reskill also in it now. That's how this works. Now, whatever values you want, you can modify it. If you want to make this run on a Raspberry Pi, it can very well do that, because we can have Python 3 running on Raspberry Pi, and then we can have like libraries that can collect information from sensors, and then we can have those values in this JSON, and then it will get serialized and then it will publish it to IoT core. Okay, so this is like the Python way of using the AWS IoT SDK. There's like one more method, which is like M5 stick C+. Now, this is a device that has ESP32 microcontroller in it. You can know more about it by just doing M5 stick C+. This is from a company called M5 Stack, and then when you look at it, it has like a lot of peripherals that it comes along with. It looks like it is in the size of a finger, and it has a display. It has like 3 buttons. It has multiple peripherals. It has a vibrator in it. It has LED in it. It has an accelerometer in it. So this comes with a number of stuff. Has a microphone, IR transmitter, red LED, 6-axis inertial motion unit, and it has buttons. It has an inbuilt battery as well. It has a buzzer. So it comes with a lot of things. Now, in order to program this, we have 3 options. We can either program it with MicroPython or the Arduino IDE or UiFlow. UiFlow is like such a nice way to program it with very much ease. So I'll quickly show you how we will be able to publish it with UiFlow. Now let's say I have this device, and if I want, this is like the M5 stick C, and I want to program this one so that it will be able to send messages to IoT core. For the first time, if you used MicroPython or Arduino to program it earlier, you will have to like have the software called M5 Burner in your computer. So M5 Burner is like, it uploads the base level program for this device. So I can connect it to my computer with USB. And let's say I click on stick C. Here it should have the COM port now. And then in here it says stick C plus. You can click on burn and then it will upload the, first you will have to download it and then upload the firmware. It's like a bootloader that you need in order for you to further develop programs with UI flow and then upload, make the device do something. For example, let's say I'll quickly, since I have uh, done that already, we need another software called as UI flow. This UI flow, we can either have it in our computer or with the browser. During the burning of bootloader, if we have configured the device to connect to a local Wi-Fi, we will be able to program this from directly the browser based method. Otherwise, we will have to use USB in order to do that. Okay, so I'll select the port, select core 2. When you hover over it, sometimes it shows you the names, but the fourth on the top row, fourth column in the top row, it's like M560 plus. So I'll click on that and then select it. Let's say I simply want to have like a very simple program that blinks the display. So I'll click on loop and then I can do repeat 10 times, or I can simply have a loop that keeps running forever. And then in this UI, I can have the screen background color to red. And then let's say I want to give a delay. So I'll do wait. So I'll have to find the timer thing in here. Event. Time. Okay, in the timer there is like wait 1 second. Okay, so I'll put this. I'll make red change to, let's say, white, and then I'll make it wait for 1 more second. So this is like a very simple program. If I just upload it, the way I do it is like on the bottom there is like this upload button. When I click on it, it will get uploaded, the device will get restarted, and then within a matter of minute you should see it changes from red and white. Every second it keeps changing. So that's like a very simple program of how you can do things. Now let's say what I want to do is I want to build like a very simple project that does a few things. So what I will do here is M5 company itself has created modules like this. There's like RFID module, there is like environmental sensor module. So I'll use the environmental sensor one now. I'll connect the cable to this one and then the other end of the cable to this device. I'll put back the USB as well, and then I'll make this, I'll put this into USB mode so that I can program it again. Okay, I have a program already for this one. I'll show you how it works. So in this URL called github.com, things cool, reskill, dive into AWS IoT. In devices, I already have something called as M5 SCP ENV2. So what we will do in there is, okay, first let me refresh this and then I'll open that file that I have, devices M5 ENV2. So in here, what I have done is like I have attached a unit called ENV2. There are two types of peripheral devices that we can attach to devices of M5 brand. When you click on plus, it will ask you like what type of module do you want to attach. I have selected ENV2 and this is my program. So I'll go through this one. So here I will do one thing, which is like I will want this device to get the environmental sensor data and then send it to AWS IoT core. There is like something coming up. So this is something that we will build. We have a device called ENV Monitor 1. So what I will do is like I'll quickly create a new device. Things, create a single thing, ENV Monitor 1. Is that the name? Yes. Okay. And let's say I do next, download the certificates. I'll store it in the folder called env monitor 1. I'll activate it. For simplicity, I'll just attach the allow all policy for now. Register the thing, it's done. Now what I can do is like I can go to the MQTT test client and then subscribe to all the topics and just wait for it to send the messages. Okay, so here the program, the way it works is like this is how it looks. First thing I need to set whatever is the thing name. I call it env monitor 1, and then I want this device to connect to local Wi-Fi. It's called thing school, and then the password is password, and then I want it to get the time from the time server from this us.pool.ntp.org, and then I need to specify whatever is the host name. We know the host name, where to find it. So I'll have to quickly go to settings and then I'll need to enter it. A19HSM. KOL. Okay. Can dash ATS dot IoT dot US East 1 dot Amazon AWS.com. Am I right? Dash ATS US East 1 Amazon AWS.com. Okay, perfect. And the port number is 30. We wanted to have the keep alive session at 30, and then we need to give the certificates. The way we will put the certificate, we will click on this plus sign here, and then I'll upload those certificates here. I need to put the certificate and then the private key. And once I have uploaded it, I need to click on key file and then select private key, certificate file, and then select the certificate. Initially, we make the timer status as 0. And then what we do is like there's a button on this device, the M5 you see, like when I hover over it, you can see that it is like glittering. Now that's the button. It's called a button. So when I press the A button, so basically I have this mechanism where when I press it, it starts the timer and then it starts publishing the message. Later on, if I press that button again, it will stop the timer and it will not send the message again. And also I'm making the LED on the device turn on or off. If it is on, I mean, if it is publishing, it will have the LED on, otherwise not. Now, what does the timer do? Timer callback is like it will publish the time value in here, published on, you see here in the black. Beneath that, it will put that whatever time it published recently in, and then it will also publish to this topic called as reskill slash whatever is the thing name slash pub, and then the attributes it will publish is like whatever is the timestamp, temperature, pressure, humidity, and device id. So 5 keys, key value pairs, it is like publishing. Now let me quickly, and we have this block. So basically the device needs to update itself with the labels on the display. So that's the reason why I have this show labels function, and that's what I've called it here. Now let me upload it. Okay, it got uploaded. Now within a few seconds, I should be able to click on this and then the messages can start coming in here. Okay, so I'll press this. When I do that, an LED, red LED will also start uh, glowing in the device. Okay, now that it has started, one like the periodicity I have set is like once in 5 seconds. And yes, we get the messages rescale slash whatever is the thing name slash pub. It has this timestamp, temperature, pressure, whatever is the device ID, which is the client name, and whatever is the humidity value. So this is like one way of how we can like provision an IoT device with very simplistic method. So it connects to the Wi-Fi, local Wi-Fi, and then connects to IoT core, and then it starts publishing the data. We will come back to that. I'll exit this for now. Okay, so we just saw how we can program from M5 stick C plus. Similarly, there is like ESP32. I mean, stick C plus is not easily available in India, so I've also thought of how we can use ESP32 board, which is like we get it in like $500, and then we can attach any sensor to it, and then we can upload values to AWS IoT Core again. Now, the way we could do that is like I have this device. So this is the ESP32, and then I have attached a sensor module to it. It's like a Bosch BMP 680 sensor module. It communicates with the ESP32 in I2C protocol. Now that gets connected. The microcontroller runs the program, so it fetches information from that sensor and then it sends data to IoT core. How can we do that again? So I'll stop this device so I don't get any more messages. So I'll clear it. So no more messages coming in here. And what I will do is like minimize this one. And we have in that same GitHub repository that I just talked to you about, there's also this folder called as ESP32 BME 680. When you click on that, you will find both the INO file and secrets.hs. Secrets.h. So I'll click on that, I'll open that Arduino file, and I'm assuming like you might have worked with Arduino already. So this is how it works. Like I have put the libraries. So some of the libraries that may not be available already is like Adafruit BME 680, and then this Adafruit sensor, and also Arduino JSON. So these are some of the things that you may have to install by going to Sketch, include library, and then manage libraries. From there, you can download those libraries. Since I have that already, like I'll skip that. Okay. Run it again. Okay, in here, like this first tab has all the program, and then here we specify like it should use the root certificate, thing key, whatever is the endpoint, and it has a logic with which we specify whatever is the timestamp, the device ID, and what sensor does it use, the temperature, pressure, humidity, all those values and stuff like that. So again, this will upload the data in the upload frequency that we specify here. And all these constants are defined in this, the other tab called secrets.h. Now in here, we need to specify like what are we doing. So I'll quickly go ahead and then create one more device. So I'll go click on things, create. This time I'll call it ENV monitor 2. Isn't that the name we wanted it? Yes. So EMV monitor 2 and then next, download the certificates. Activate it. Attach a policy. I'll just do allow all so that I don't have to configure a lot. Okay, now that this is provisioned, what I can do now is like go back to test client and then subscribe to this. So when the message comes, it will just show up here. Now the thing name I know is like ENV monitor 2. For this BME sensor, we can, in order to get the altitude and pressure, like we need to specify whatever is the sea level pressure in the current region. This is like a constraint that was already there, so I just let it be. I want this device to connect to this Wi-Fi. Password AWS endpoint. I can copy this from here and then I can paste it, and it has the port number, which is good. And then I want it to publish to reskill slash env monitor 2 slash pub. Okay, and what I will do next is there's a subscribe topic, but this device does not do any of those things. So upload frequency is 5 seconds, it's in milliseconds, and the root certificate, it's a constant, so I have already populated it. A couple of things that we need to specify, whatever is the device certificate and the private key. So the device certificate, we can find it here. Certificates env monitor, can right click it and open with text edit. If you are on Windows, you can use Notepad to do that. So text edit, open. Let's copy this and then paste it here. Similarly, we can put the private key as well. So private key, open with text edit. Copy this entire thing, close it, paste it. Yes, we have now configured everything that we need. So let me connect this to my computer. Okay, now I have to select tool CSP32 developer module. If you don't have this one, you need to click on board, go to boards manager, and then, okay, first you will have to like add in the, preferences, additional boards manager, you have to put this file. If you just Google it, you will be able to find all that information. And then once you do that, in the tools in the board, you need to specify like ESP32 developer module and whatever is the port number. For me, it's USB serial 0001. Okay, good. I'll now upload it. While this gets uploaded, most of these ESP32 boards have this thing that when the upload starts, we will have to hold the boot button for a couple of seconds until the uploading begins, and then it will start uploading. Okay, it starts uploading, and then I'll have to click on this boot button for a few seconds, and then okay, now it's uploading. Okay, now that it has done uploading, I can open serial monitor and then see like how it is behaving. It says connecting to Wi-Fi, Wi-Fi connected, time configured, connecting to AWS IoT. That's also connected and it is publishing the messages now. If I come back here, there are more key value pairs that I'm sending from this ESP32 device. So you can see there is like so much of numbers coming in. Let me resume this device to send messages as well. So we will have like both of those things coming in. Okay, we have it. Let me pause this one. Okay, so here you can see that both of these have timestamps, but the timestamp is like kind of different. This has like 9 digit, this one has 10 digit. We will get to that later. Temperature, this one has like ends with 2 decimal points. When I did it from Arduino IDE for ESP32, it does not have that, so it has like a different value. And similarly, pressure from one sensor is different from the other sensor. Similarly, humidity is also different from one sensor to the other sensor. Anyway, now that the data has started coming in, we will see like what can we do further and then how can we proceed. Okay, so this is how we can like program an ESP32 board to communicate with AWS IoT core. No, this is like a simple IoT project. We will evolve this one in phases so that we understand the other AWS IoT services as well. Now, this one we have already seen that ENV Monitor 1 and ENV Monitor 2, it sends data to IoT core currently. If we want to store that data, we can easily have a rule that can store it to DynamoDB as well. So let's say I do this thing. So I can go ahead and then click on Act and then Rules. First, let's say I have a different DynamoDB table. And what I'll do in there is create table. I'll say env monitor and then partition key, let it be the device ID. This one needs to be timestamp, which is a number, and I can have a sort key as device ID, which is a string, which is good for us, and then I'll click on create. Now this table will be empty, so I'll go ahead and then quickly go to rules and then I'll do dynamo. I'll create a different one, create env dynamodb. And in here I want, I can either specify that get me all the key value pairs, or I can specify which fields do I want. Let it be all for now, and then I want this to have, let's say, reskill slash plus slash pub. The plus will actually be like the wild card for both env sensor 1 and 2. And then I want this to store the messages in DynamoDB. We will say that it has to go to env monitor and then create a role that ddb env monitor, create the role, and then it gets attached, add the action, and then I can go ahead and then create the role. This one we have to wait on it. Okay, it's done, and then enable it. Now we know that both of these devices are constantly sending messages. So if I go to DynamoDB and then refresh the table items, here, okay, the values have started coming in. There's EME monitor 1, monitor 2, whatever values we have been getting, it's getting stored in here. The sensor with ESP32 developer module, it gives like some extra information, which is like altitude and gas resistance as well. Whereas the M5 stacks ENV2 sensor, it gives only these three values. Anyway, so the data has started coming in once in every 5 seconds that this data comes. So you can see like 78, 83. So there are like 5 seconds gap. We will look into what these time differences. Okay, well, it will be a good time. These timestamps, it's like the Unix timestamp, we call it. So the number that you see here, it's the number of seconds from a particular date. So Unix time, if you do epoch time, so is another name. So currently for the current date, which is like 17th hour, 37th minute, 31st second in GMT for this particular date, the timestamp for this one, it's in like 10 digits because it's those many number of seconds since 1/1/1970. So that's how it works. Is there, yeah, this is the current timestamp and it says this is the number of seconds since Jan 1 1970. No, there's like a different type of timestamp as well, which calculates from 1/1/2000. Uh, so what has happened with us is that the ENV monitor one, which is based on M5 stick C plus, it is giving us a timestamp based on 1/1/2000. ENV monitor 2, which connects to a different time server, it gives us like the timestamp based on 1/1/1970. So that's the reason why you see the difference in these two timestamps. We have to find a way of how we can work with it, but we will go ahead with that in a bit. Okay, now from the EME monitor, the data goes into IoT core, and then there is a rule that sends data to DynamoDB. We can have another rule, and then we can specify some kind of threshold as well. For example, let's say we see that the temperature, it's somewhere around 29, 30. So if the temperature goes beyond 30, let's say I need a notification. So what I can do is like I can go back to rules and then I can do this. Let's say publish SNS. I'll change this, edit this a little bit. I'll say select temperature from reskill slash plus slash pub where temperature is greater than 30. So I can give a SQL query like that, updated. So if this gets satisfied, it will take that temperature value and then it will send it to me as an SNS push notification. Okay, now that this is done, it's enabled. So I don't know if the temperature will go beyond 30 now, but I can do something from SNS publish. Okay, these are the old messages. Now I'll just hold on to this sensor for a bit and hope that it will increase the temperature. From here and then let's see, I subscribe to all the topics. Temperature is 28 now. In the other one, it's 29. It's rising. It has gone beyond 30.26, right? So I should have received a message. Should have received an email. Okay. You see here it says like 30.26, 31.03, 31.23. So once it reduces, that message will not come any further. So that's how we can have a rule that does this task. And then we can have like, I mean, just like how I have the environmental sensor module for the M5 stick C, there are other modules as well. Like I can have like an RFID, and then I can have light bulb with which I'll be able to like control these things. So let me quickly show you how we can do it. So what I will do is stop this one, take it off from here, and then move this as well. I'll use like another M5 stick C, but before that, let me connect it to the RFID module. Okay, so I'll quickly again go to things, create a single thing, call it RFID. Next, create the certificates, download it to the RFID folder. Activate it, attach the allow all policy, register it, done. So what I will do now is go back to UI flow, open the other program that I have. I will save this for now in devices. Call this save replace, and then I'll open the other one which has MSCP RFID. Okay, open this one. Thing name is RFID, and I want it to connect to things cool, and then the password is password. Let me select this. Okay, and I'll have to give the host name A19. Just okay, I'll put the certificates in this certificate, and then the private key and then certificate. So what this will do now is whenever an RFID card comes, I have kind of created a program. What it does is like it verifies. Okay, when a RFID card is tapped, it will send that RFID card's UID, RFID UID. It will publish it to AWS IoT Core. So that's simply what it does. Okay, now that I have configured it, provisioned it, I'll download the program. I'll flash the program onto the device, which is done now. We can go ahead to MQTT test client, and then we can subscribe to I want reskill slash RFID slash UB. I'll subscribe to that topic. And when a message comes into that, we will be able to see it here. So let me start it. So I'll place this card. So it has sent this UID with this timestamp. The device ID is RFID. If I place another RFID card, it will basically show something else. Okay, I think I didn't give it enough time for it to read the UID. So do that. And here it is. It says this is the other card's UID. Now what I want to do is I want to program one another device, which is M5 Core 2. So in this, we will actually depending on which card I place for one of the cards, let's say I turn it on or turn it off, something like that. Okay, I'll save this program and then I'll do save, replace. Okay. And now I'm going to use a different hardware just to make you see how that works. So I'll use this M5 Core 2, and this is how it looks like. And in here, we need to configure a few things. So we will have to do these ones. Okay, let me disconnect from this. Since it's battery enabled, it is already uh, turned on, so I don't have to plug it in all the time. But because I have to program this device, I've connected it in now. And what I will do is I'll select the COM port of this. Okay, and I will create a new device called light bulb. So go back to things, create a single thing. Let's call it light small bulb bulb. Next, create certificates. Light bulb is getting created. And I will activate it and attach the allow all policy. Okay, that's done now. So what I will do is I'll specify that the name of this is called light bulb. It has to connect to this uh, Wi-Fi, and I need to specify A19 US East 1 dot Amazon AWS.com. Okay, I need to put this into the programming mode. I have put this one in programming mode now, so now it says connected. And what I'll have to do is like give the thing name, specified the Wi-Fi SSID, gave the host port, everything, and then need to give the certificates. So I will do now certificates light bulb, certificate upload, similarly private key upload, and then it had something already, so I'll have to just see what was the certificate that we just created. Light bulb starts with 7C. Key file 7C private certificate 7C certificate. Okay, and then what we do is like we start AWS, we publish something that just says status connected, which is okay. And then we also subscribe to this topic reskill RFID pub that the other device publishes messages into. And then we kind of verify if the RFID UID, if it is 37AC blah blah. Depend if we place this M5 stacks card, then the background color has to be white for the LO device. Otherwise, if I place the empty RFID card, then it has to be like black. No, that's the program we have. So I'll go ahead and then upload it. Okay, upload successful. Now what I will do is like come back here, clear this thing, and then it has started the program. Initially, we are setting the background color to black. So the screen has become black now. If I place this M5 stacks card on RFID, you should see a message. We have to turn this on, then should have done this. Okay. Now we see that because it was M5 stacks card, this 37AC blah blah whatever, because that's what we are comparing it here with. So the device has turned on, and then I'll place this white plain card, and then now it has turned black because it's something else. Similarly, like I only have 2 cards for now. If you change the card, and then depending on that, you can do it. But one of the things that you see is like this M5 stick C is sending its message all the way to AWS IoT core, and this M5 core 2, it's receiving, subscribing, and receiving the message all the way from AWS IoT core. So although like these two devices are right next to each other, let's say even in the real setup, it could be like the RFID card and then the light bulb actually that allows a hotel room to get opened. There's no point in these devices talking to AWS IoT just to make sure that this gets opened up or a light gets turned on or something like that. Anyway, so these are like 4 devices. Probably this should have given you like a thorough understanding of how we create a device, how we configure those certificates in the device, and how do we send data to IoT core. And once the data comes to IoT core, how can we have rules with which we will be able to store data in DynamoDB or Amazon SNS, stuff like that.